Okay. The shape operator of is a linear transformation. So any linear transformation we can write in the form of a matrix. So here with the help of that matrix itself, we are going to define the Gaussian and mean curvature. Okay. So here you can see the definition, right? And before going to Gaussian and mean curvature, if we are knowing that any linear transformation is provided to us, so with the help of that linear transformation, you can write down the matrix, right? With the help of some basis. If suppose it is a standard order basis or any basis. So with the help of that basis, you can find out the matrix corresponding to that linear transformation. And even you can see here a linear transformation can be expressed in the form of a matrix whose rows represent the linearly independent set of vectors like the base vector. For the given linear transformation, the value of the determinant of a matrix and the sum of the diagonal elements is always same irrespective of a basis. That means if you change the basis, there does not it will not give any effect on the sum of the diagonal elements as well as the determinant of the matrix. You can check by the some example. Take any linear transformation and write down that linear transformation with the help of some different type of basis. For the suppose you are writing for R2 space, so take any two bases of R2 space. With the help of that, you can write down the matrix corresponding to that and check whether the sum of the diagonal elements as well as the value of determinant of that matrix with two different bases is same or not. Rather, it will be same, and that's why the Gaussian and mean curvature has been defined. Okay, so here you can see the definition. The shape operator S is a linear transformation for any point P of the Gaussian curvature K of P is defined as. What is Gaussian curvature? It is nothing but the value of a determinant. Why it is written the value of determinant? Because with the help of different bases, you are getting the same value of the determinant for any linear transformation. Okay, and here, what is a mean curvature? Mean curvature is defined as it is a mean, so that's why we are taking 1 upon 2. Trace of S. What is a trace of S? I hope you are knowing what is a trace. Trace is nothing but the diagonal elements. Okay, so here also some of the diagonal elements are same with respect to any basis. If you change the basis, there is no change in the sum of the diagonal element. Hence, the mean curvature is defined h is equals to 1 by 2 trace of s. What is a trace of s? It may be as we have TPM. What is a TPM? It is nothing but tangent plane, right? Tangent plane. As it is a tangent plane, so it is restricted in 2D plane. Okay, so hence the how many elements are there in trace of S? So we will have only 2 cross 2 matrix. So what is the trace of S? It will be some A11 plus A22 divided by this 2. Okay, so here what is a Gaussian and mean curvature? It is nothing but Gaussian curvature is nothing but the value of a determinant of S, and mean curvature is nothing but the trace of S divided by 2. And if the next lemma tells us that if K1, K2 are the principal curvature at a point P, then show that the Gaussian and mean curvature are given by. Okay. So what is given to us? K1 and K2 are the principal curvature. Those who have attended the last lecture or those who have seen the last lecture, they can understand what is a principal curvature. These are nothing but the simply maximum and minimum values of the normal curvature. Okay, so if they are maximum and minimum values of the normal curvature, then we have to show that the Gaussian and mean curvature are given by, right? So first we will write down what is a shape operator in the direction of E1. So let us define E1 and E2 are the principal vectors. That is, with the help of that E1 and E2 itself, we are going to find out the principal curvature. That is the maximum and minimum values of the normal curvature. Okay, and E1, E2 forms the basis for TPM. Why E1, E2 will form the basis for TPM? Because these we are selecting in such a way that uh, that means they are nothing but the maximum and minimum values, and with the help of that only we TPM. Uh, that is what is TPM? TPM is nothing but the tangent plane. So that's why they are forming the basis for the tangent plane. So hence we can write S of E1 is equal to K1 E1, S of E2 is equals to K2 E2. I hope you can understand this from the last one. S of E1 is equal to, we have written K1 E1, and S of E2 is equals to K2 E2. Right. So with the help of that, we have written the values. Now simply we have to write this two equation in the form of a matrix, that is S of E1 is equals to K1 E1, and this E1 we have to write down here. So whatever the coefficients of E1 we have to write down as in the form of a matrix. Okay. So S of E1 is equals to, we are writing K1, and what is the coefficient of K2 here? It is 0. And in the second one, what is the coefficient of E1? What is the coefficient of E1? It is 0. What is the coefficient of E2? That is K2. So just after writing this, we will get the matrix of this linear transformation, and hence we can find out the value of determinant. And hence it is, what will be the value of determinant? This is simply K1 into K2 minus 0. So hence we will get the value of the Gaussian curvature is nothing but K1 into K2. Correct. So similarly, we can find out what are the values of the diagonal element. What are diagonal elements? K1 and K2. What is the trace sum of a diagonal element? That is K1 plus K2. Divided by 2 will give you the value of the mean curvature. Okay. So here again the things are given that we have discussed in the last lecture. What will happen if the K of P is greater than 0 or less than 0. So here we have K of P, if it is greater than 0, then K1, K2 have the same sign. You can see here what is the value of K of P or K, that is K of P if it is K1 into K2. Okay, this K1 in K2, if they are of same sign, that is if K1 is positive, K2 is also positive, the resultant capital K will be positive. That is a Gaussian curvature. And if K1 is negative and K2 is positive, at that time this will be uh, negative. Similarly, if both are negative, obviously your Gaussian curvature will be positive. Correct? So these are the things which we have already studied while studying the normal curvature and its properties. So these are nothing but K1 and K2 have the same sign, and if they have opposite sign, what will be the effect? Okay. So next we have studied what is a saddle surface. I have told you that you have to keep an handkerchief in such a way that you can have a image like this. Okay, with the help of that, we can get a what are the values of a Gaussian and mean curvatures. Okay, and these are the theorems related to that. You can go through this theorem. It is very easy. So actually, what you have to do is take any two linearly independent vectors such that SV cross SW is equals to K of P V cross W. What you have to do in this? You have to prove that K of P is equal to SV cross SW divided by V cross W. Next, we have to prove that H of V, that is mean curvature, is SV cross W plus V cross SW divided by 2 times V cross W. For that, what you have to do is, you have to take any two linearly independent vectors V and W. With the help of that, you have to write down S of V is equals to AV plus BW. Okay, since V and W are linearly independent tangent vector, they obviously forms a basis. Why? Because it is given to us that what is a domain and codomain of a shape operator. It is a 2D because it is tangent plane. So as it is a tangent plane, it needs only two linearly independent vector to form the basis. As we are knowing the dimension of the domain space and codomain space. So hence we can have any vector S of V, because the resultant is also going in the TPM. No, what is a S? S is a mapping from TPM to TPM. So what is S of V? It is also going in the TPM. So hence we can write S of V and S of W. With the help of that, what we have to do is again write down in the form of a matrix. Again go through the definition. What is the definition? Determinant of S is nothing but the Gaussian curvature. And what is a mean curvature? It is nothing but 1 by 2 trace of S. And hence with the help of that, we have to just put up the value and we can solve and we will get the result. Okay. So these are the theorems related to that, and we have to go through these theorems, and some examples are there based on the Gaussian and mean curvature. Okay, before going to that, I must tell you that you should go through this theorem, which is after the normal curvature. This theorem is very important. Note down this. Actually, it is on, I think, page number 175 on your Shivaji University notes. What is given to us? P is umbilic point of the surface M in the shape operator. Then we have to say that shape operator is just a scalar multiple of K1. that is k1 is equal to k2. That is nothing but the maximum and minimum values of the normal curvature. If p is non-umbilic point, that means if k1 is not equal to k2, then we have to prove that s of e1 is equals to k1 e1, s of e2 is equals to k2 e2. Okay, what is umbilic point? A point P of a surface M is called umbilic point of a if the normal curvature is constant on all the unit tangent vectors. If normal curvature is constant, because we have seen that it is possible to have a different normal curvature at different point of the surface, as we have already studied for our example of a cylinder, because in the cylinder if you go through the circular, then you can feel like you are having a sphere or circle, then at that time you can have the shape operator is minus 1 upon r of that vector. And if you go through the vertical surface, then you feel that you are having a plane. So what is the shape operator for the plane? It is 0. So that's why the normal curvature is also different for the different surfaces. Even we have seen in detail what is a saddle surface. For the saddle surface also we have seen there are three normal curvature. First is 0, where normal curvature will be 0 on the x and y direction, right? And for the direction x equal to y, what is a normal curvature? It is positive. And for the direction x equal to minus y, what is a normal curvature? It is negative. So that's why the normal curvature is different for any surface. It may be same or different. So in the surface, or if you are getting one surface in which the normal curvature or the shape operator is same, then that type or that called the umbilic points. And for the example of a sphere, we have seen that what is a shape operator? It is minus 1 upon r times that vector s of p is equal to minus 1 upon r into v. Then what will be the normal curvature? It is minus 1 upon r. So here you can have the example of a surface. We have the normal curvature is minus 1 upon r. So that's why it is nothing but such a surface is called a umbilic surface, because at every point you are getting the same value of the shape operator. Okay. So if here you have to go through this theorem that P is umbilic point and P is non-umbilic point. No doubt this will be, actually it is not a theory for you. So you have to go through this theorem. You can understand this. Simple calculations are there. What you have to do is first you have to write down k value of k, and then you have to evaluate with u of theta. What is u of theta? It is any vector which can be written in the linear combinations of e1 and e2. Then use the definition of the normal curvature, that is s of e1 e1. Instead of e1, instead of u, it is written theta e1 plus sine theta e2. Then you have to evaluate this value of s of e1 s of e2, then you can get the result. Okay, go through this all the examples that are solved example. Actually only the definitions are important, because next are only the example. You can solve the example. What you have to do for solving the example, here you can see, simply you have to find out fxx, fxy, fxy. Then these are the things you have already done. What is fx? That is a derivative function f in with respect to x. What is fy? Derivative function f with respect to y. Correct? So in this way, you have to just see this theorem, so that you can understand what is umbilic and non-umbilic points. Solve these exercise example. Find the quadratic approximation near the origin of the surface. Just like we have done for a curve, find the quadratic approximation of the curve. Here also it is given that what is the quadratic approximations of the curve surface. What is quadratic approximation of a surface? Here we are provided with the f of fxy, because we know the Taylor series for a single variable. Here we have written the Taylor series for two variable fxy. That is, if suppose it is with single variable, fx is equal to what you have write, f of 0 plus h into f dash of 0 plus h square by 2 factorial f double dash of 0 and so on. But here it is with two variable. Why it is with two variable? Because we have a surface like z is equal to f of xy. If we are having the surface is expressed in the form of z is equal to f of xy. So here we have to write down the Taylor series for two variable, and then after that we have to follow the same procedure, find the values of fx, fy, whatever we have in the series, and then put up the values and you will get the result. And this is what the quadratic approximation of the surface M near a point P. Solve those example and even go through this all the Gaussian and mean curvature example. अभी एग्जाम्पल ही है, आपको सिर्फ ये जो थ्योरम्स है ना, ये सब लोग आपको क्या करना है, सिर्फ एक एस ऑफ वी एस ऑफ डब्ल्यू ऐसे लिखना है विद द हेल्प ऑफ टू लीनियरली इंडिपेंडेंट वेक्टर और विद द हेल्प ऑफ टू लीनियरली टू वेक्टर फील्ड. What will happen if we take a vector field? What will happen for a tangent vector? And then you have to solve the example. Before going to that, I will tell you this. These two formulas are very important for the set exam. A of x is equal to ln minus m square eg minus f square equal to gl minus en gl plus en minus 2 fm divided by 2 eg minus f square. Okay. I hope you can understand this. I think it is on the page number 189. Those who are want to prepare for the set exam, these formulas are important because at least one question is there. What is Gaussian and mean curvature for the given surface? Okay. Again, here we have whatever we have done for just now, that theorem we have used, and after using that theorem, we can have the value of k as SV dot v. That we have named it as instead of taking any vector v, we have written xu. What is xu? That is our x is nothing but our mapping x. We have x of uv is equal to, we have defined now patch computations. While patch computation, so you have to just differentiate x with respect to u and then with respect to v. That we have renamed the value of this term x sxu xu, that is nothing but L. Sxu xv, that is nothing but M. And hence, with the help of that, these you already know. What is xu dot xu? It is E. What is xu dot xv? That is F. That we have studied already in the case of regularity. How to check the given mapping is regular or not. While checking the mapping is given regular or not, we have written this. And hence you get the formulas for the Gaussian and mean curvature. Okay. If you're having any type of a doubt, you can ask. At least for the last lecture, you can unmute yourself and ask the question. Hello. ऐकू येते माझ्या?
Yes, ma'am. Hello, ma'am.
No.
Yes, ma'am.
Generally, हाँ? Hello.
सैडल सरफेस का एग्जांपल मैम.
वो ऑलरेडी लेक्चर में लिया है, लास्ट लेक्चर में. आपने रिकॉर्डेड लेक्चर देखा नहीं होगा सैडल सरफेस का. देखा है क्या लास्ट लेक्चर? हेलो. हेलो. Okay, let me demonstrate here only. What you have to do is, अगर आपके पास कोई हैंकरचीफ है, actually I need one person for the example of a saddle surface. Suppose this is a handkerchief, actually it is a page. So what you have to do is, you have to keep it in the form so that it will be just like a saddle surface, right? आपको यहाँ से actually पेपर इसलिए फोल्ड नहीं हो रहा है ना, तो आपको ऐसे पकड़ना है उसको, ऐसे यहाँ पे, और यहाँ पे थोड़ा सा फोल्ड करना है, करेक्ट. So actually I need a two person here so that one this and another will have आपको फिर यहाँ पे क्या करना है. So here you will have this is x, y and z, right? X, y, z axis. So आपको यहाँ पे क्या फील होगा? It is just like a plane surface, right? Plane surface के लिए obviously shape operator zero है. Why this is so? You have to go back to your lectures. You have to see those lectures so that you can understand why the shape operator is zero for the plane surface. Okay, क्या करना है आपको? ये वैसे पकड़ना है और इस ये जो बीच में वाला हिस्सा है उसको थोड़ा सा. Actually, paper is like fold नहीं हो रहा है. You have to take a handkerchief in such a way that you can have the figure like a saddle surface. Okay. So hence, with the help of that, you can have the saddle surface, and you will after seeing that saddle surface itself. With the help of two people, I can do this. You have to keep your handkerchief in such a way that you can feel like it is a saddle surface, and wherever you are going to plot x, y and z axis. So in the direction of x axis you will feel like आप अगर हाथ रखते हो तो आपको प्लेन सरफेस के जैसे लगेगा. अगर आप इन द डायरेक्शन ऑफ x इक्वल टू y, x इक्वल टू y कहाँ पे होगा? अगर प्लेन है तो 45 डिग्री के एंगल पे होगा ना. सो एट दैट टाइम यू विल फील लाइक द सरफेस इज मूविंग, सरफेस आपका इंक्रीज हो रहा है. सो एट दैट टाइम व्हाट विल बी द नॉर्मल कर्वेचर? इट इज पॉजिटिव. Okay, and the direction of x equal to minus y, the normal curvature is negative. Anyone else have the questions? Hello. याच्यानंतर मॅडमचा पण लेक्चर आहे हा. See, no doubt this will not be completely last lecture. If you are having any type of a doubt, you can tell me so that we can take a one more lecture. So for the clearance of doubt, because all the syllabus is completed, but still if you have a doubt, you can. Yes, the syllabus is up to Gaussian and mean curvature. You can see the syllabus, no? Let me show you the syllabus for this. I hope this copy is with everyone, every student, because syllabus should be there with you. Uh, okay. Functional ADM, linear algebra, differential geometry. So this is soft core paper, 80 numerical technique, and we'll go directly for differential geometry. What we have is shape operator, normal curvature, and Gaussian and mean curvature. We in the unit 4. So let us go one by one what we have seen in the. Is the screen is visible for everyone? Differential geometry syllabus जिससे कहा.
Yes, ma'am.
So we have studied what is tangent vector field, frame field, reparameterization in the unit 1. Then we have seen directional derivative, differential forms, df,
Ma'am.
speed of, that is if curve alpha is given to us. Suppose you are moving on a bike, that will show you the path of the curve, and that speed of bike will give you the speed of curve. And in the unit 2, we have gone with the Frenet formulas that will Without knowing the curve itself, you can say what is a normal curvature, what is a Gaussian curvature, normal and tangent, binormal, what is curvature K, and torsion. That is, without knowing the curve itself, you can say what is turning, what is twisting of the curve. Next, we have seen isometries, that is translation, rotation, orthogonal transformation, and we have seen the relation between them also. That is, whether every orthogonal transformation is isometry, whether every isometry is orthogonal transformation. If it is so, what should be the condition f of 0 is equal to 0? That theorem we have proved. Next, we have seen what are the finite approximation of the curve. Next is a covariant derivative with respect to tangent vector as well as with respect to vector field. Next, in the third unit, I hope you are not aware with the third unit क्योंकि किसी ने भी lecture नहीं देखा है, I think so. Calculus on the surface means what? We are going to study the surfaces from the third unit onwards. So after getting the surface itself, first before defining the surface, we have defined coordinate patch, proper patch. Then we have gone for the definition of surface. And definition of surface was somewhat difficult, so that's why we have gone with one theorem that how to show that any given object is a surface or not. For that, we have to simply show dg is not equal to 0. Next, we have seen patch computation. That means any 3D object how to create. That means whatever the straight line we have, that we have to convert into the form of the curve. क्या करना है आपको? आप suppose you have one rubber sheet, then you have to stretch it and bend it in the form of the one 3D object. और आपके पास अगर पतरा है तो उसको हथौड़ी से मार के उसको कुछ 3D के ऑब्जेक्ट के फॉर्म में कन्वर्ट कर सकते हैं. जस्ट लाइक अ हाफ स्फीयर, right? Then we have seen parameterization, differential functions, and tangent vector. What are the tangent and normal on the surfaces? Because we have seen what is tangent and normal on the curve. Then we have generalized those concepts, and on the last chapter we have seen what is a shape operator, normal curvature, and Gaussian and mean curvature. Okay. Is there any doubt still? If you are having any type of a doubt after seeing the lecture, and then also you can say that ma'am take one live lecture so that we can clear our doubts. Okay, I will share the notes. Gayatri Brahmani.
Hello, ma'am.
Huh.
Ma'am, what about second internal of DG?
Actually, what I have done is I am going to multiply it by 2, so we will get the marks. Is it okay? Should I take the internal? Hello?
Ma'am, it will be better if you take once again on second or third unit.
What I have think no, because if I am concentrating on the second internal, you will be only studying the second chapter because you have to study the third and fourth chapter also. और अगर मैंने इंटरनल डिक्लेयर किया उसके एक दिन पहले ही या उसी दिन मैंने शायद बोला कि मैं इंटरनल नहीं ले रही हूँ. सो आई होप यू हैव स्टडीड क्योंकि मैंने बहुत पहले डिक्लेयर किया था कि मैं इंटरनल ले रही हूँ.
हाँ, yes,
वो
ma'am.
पीरियड में आपने स्टडी किया होगा. मेरा मोटिव वही था कि आप इंटरनल डिक्लेयर हुआ इसलिए एटलीस्ट सेकेंड चैप्टर कंप्लीटली हो जाना चाहिए.
Yes, ma'am.
What Mahima tells 2 is okay. Multiply by 2, okay. Actually, all students are passed, so that's why I have taken that. Yeah, I can multiply by 2 so that you can get marks out of 30. be prepared for your exams also. I hope you are knowing that your timetable is displayed. From 22 onwards, you will have the exam. आई थिंक इंटरनल डिक्लेयर हुआ था इसलिए आपने सेकेंड चैप्टर ऑलमोस्ट कंप्लीट हुआ होगा. आई होप सो. So that's why go through the third and fourth chapter also, because these chapters are also necessary. I don't know how many of you have gone through this chapter, because that are somewhat difficult to understand what is a surface, because up to now we haven't defined the surfaces and what is a normal curvature, what is curvature and all on the surfaces. So for that you have to go through the lectures more times so that you can understand. You have to utilize this time so that you can increase your knowledge. आपका जो भी टाइम बच रहा है कॉलेज आने के लिए या फिर कुछ भी चीज करने के लिए, सो एक्चुअली यू हैव टू बी रेडी इफ यू आर गोइंग टू कॉलेज ना, ट्रैवलिंग का टाइम, तैयार होने का टाइम. सो यूटिलाइज दैट टाइम. सी द लेक्चर. अगर हमारे लेक्चर पसंद नहीं आ रहे तो किसी और के देखो एनपीटीएल पे. If you have any type of a problem with my teaching, you can go through any lectures. And still, if you have a doubt, you can ask me to take again live lecture so that we can clear the doubts. We can have a discussion so that you can be clear with all the points in your third and fourth chapter. I hope you are not having any difficulty for the first and second chapter right now.
Yes, ma'am.
From the third chapter onwards, you have to see the lecture, complete this lecture. Fourth is not big one, because simply we have introduced a shape operator, normal curvature, and Gaussian and mean curvature. Only 3 points are there. Even in the third chapter also we have definition of surface and some points related to surface itself. Okay, how many of you uploaded the assignment?
Ma'am,
सगळ्यांनी
actually there are three questions of mean and Gaussian curvature, so that the third assignment still not uploaded.
No, I am asking about the not about the whole assignment, because some points are not completed yet. So that you have to go through the points and then complete a whole the assignment, and you can upload.
Okay, ma'am.
नो नीड टू वेट फॉर दैट ना. अगर आपका जितना सिलेबस हुआ उतना असाइनमेंट सॉल्व करके रख सकते हो. जैसे पॉइंट्स कवर हो गए आप कंप्लीट कर सकते हो ना.
Yes, ma'am. It's done already.
If you're done, it is good. Complete your assignment, put it on the Google Classroom so
Okay,
that
ma'am.
आपको एटलीस्ट प्रैक्टिस हो जाएगा ना कि कितने एग्जाम्पल्स, कैसे एग्जाम्पल्स होते हैं सॉल्व करने के.
Yes, ma'am.
Anyone else want to speak? See, don't assume that it will be the last lecture. If you have a doubt, you can tell me that, ma'am, this point we haven't understood. So we can take again a live lecture, or I hope from the recorded lecture also you can clear by seeing more and more times. You can clear that things. Why I'm not teaching on the board? Because many students are saying that it is not visible. So that's why it is just like a PowerPoint presentation. So hence I am doing that. I'm trying to take that pen tablet because I am not familiar with that. मेरा थोड़ा राइटिंग का प्रॉब्लम आ रहा है, इसलिए मैं थोड़ा सा प्रैक्टिस करके ही वो पेन टैबलेट पे स्टार्ट करूंगी. जैसे ठेंगे मैम लेते हैं.
Okay, ma'am.
Anyone else having the problem can ask. Okay, should I end the lecture now? If no one have a doubt.
Yes, ma'am.
Okay. Thank you. Best of luck for your studies and the exams.
Thank you, ma'am.